Introducing Pyplan for planning. You should start installing Pyplan in your computer following the instructions you can find at pyplan.org. After installing, you will have to type Pyplan in order to launch the application. Once at the app, we'll start creating a new model that we call Getting Started with Planning. As soon as we hit OK, create the environment, and then drive us to the influence diagram, that is where we go. We'll start creating a title and formatting that text node. Then we'll drag a CSV node in order to load some data. The application will show a preview of that and then guess some indexes. We'll unselect all of them. We'll provide a title to this node and accept the suggested ID. Double-clicking the node, we indicate we want to run it and display its results. We'll create a local variable called df from data frame and generate a new column named time. Double-clicking the node, it will show the just created column time. Now we'll create our first index. We will call it item type and we'll define it as the unique values of the item type column of the data frame. Double-clicking on it and it will show its values. Now let's change the title and ID of the first node. You can see how the definition has been adjusted to the new ID. As well as item time, we'll create two new indexes called sales channel and historic time. Now we will add some text nodes to organize our diagram. Now we'll create two new indexes called region and country, the same as we did before. But now we'll create a map to relate every country with a region. For that, we'll take the two columns from the data frame and drop duplicated values. And after some adjustment, we'll finally transform it to an Xarray object. We'll leave this for a moment to inspect the Pyplan library. Getting into the Xarray extension, we'll find a package of functions that will make it easier to work in Pyplan. Here we are expecting the data array from pandas function. Now we'll start creating the calculation logic. The first step will be creating a node called volume using the data array from pandas function we have just seen. We will calculate the mean values across time and inspect its results along its dimensions. You can see how easy you can create a coordinated table and graph view and start pivoting along dimensions. We can define hierarchical relationships between indexes. Take a look at the country index here. Now we will define the link of country index with the region index through the country to region map node. For that, we indicate that the index itself will be hierarchy related to the region index. Evaluating the node, you can see that the country index presents an icon indicating a hierarchical relationship. Clicking on the icon, it will display grouping alternatives, region in this case. So as soon as you click, you can see how the information is grouped to region on the fly. Now let's show the importance of using indexes. Let's create a node called volume adjustment, define it as follows. You can appreciate the item type dimension is defined inside the node, and there is no element called meet in that definition. We'll create a new node to be the result of volume plus adjustment. Adding the nodes will produce a subtraction of the element meet from volume, since that element do not exist in the volume adjustment node. That is because Xarray calculates results only for the intersection of dimension domains of operating nodes. There is no meet in the item type dimension of the result variable. One way to solve that is using the setDomain function that guarantees the integrity of calculation. This is one of the most important reasons to work with explicit defined indexes. Let's create the same value adjustment node, but in this case use the Pyplan function create.array. In this case, not only you guarantee dimension domain, but also when double-clicking the node, it is evaluated as an input table to manually provide values. We color yellow this type of nodes to easily identify manual inputs in the diagram. Now if we replace the value adjustment with the just defined node and explore its result, we can check that the mid is there. This is just to emphasize the importance of working with explicit index definition. Let's now import a module that contains an index time definition and its related hierarchies. I have that file on my computer. I choose it and indicate to merge to the existing code. There it is. Inside the module, you can see the time, quarter, and year indexes and its mapping matrices. Exporting and importing modules is how you integrate developments made by other contributors. Let's create a new node, call it base price, and link it to the existing historic sales data frame. As soon as you evaluate it, Pyplan detects it's a data frame and displays a toolbox for working with pandas objects. We will now use one of these tools to group units sold and total revenue by item type. You can see how the code is automatically generated. Analysts use that as a help to start coding the definition of the node. In this case, we'll define price as a total revenue divided by units sold. And finally transform that to an Xarray object. Now we'll create a manual input node using the create.array function. Pyplan identifies definition as an input table so that it displays a table where we can modify values. We can select, copy, paste values, and finally accept changes. Accepting, you change the definition to an Xarray object. Now let's create a node for projecting prices. Define it as the base price times 1 less the discount. Let's inspect the result as a table first and then as a graph, a line graph in the bottom. We'll edit that and select a line graph. There is the impact on the cosmetic price of the discount we entered. We'll create now another variable called elasticity. field with the default -1 value and index by item type. And then another variable called elastic volume projection, defined as follows: projected price less the self variable in the previous time period. We'll use a dynamic function here that allows referencing, self-referencing, in this case a variable in different periods of time. Then we'll define the factor as 1 plus elasticity times delta P divided by projected prices, and the final result as a base volume times factor. Evaluating that result as a table and a graph, we can explore its values. Now we'll create two other input tables called production and initial stock that will help us modeling the next step. Now the variable called product stock, which will be defined as where we are the first position in time, we'll have the initial stock plus production, and for the rest of the values, the self variable like the 1 period plus the production. Now we'll define the supply demand. In this case, we copy and paste the definition to speed up. First, there is a local variable demand defined as the sum across country and sales channel. Then, a local variable stock as the stock available at the end of the previous time period. As the result, the minimum between demand and production plus stock. Now we can correct the stock calculation, subtracting the supply demand to the previous calculation. You can appreciate there is a cyclic dependency between product stock and supply demand variables, solved by the dynamic function. We can explore the results. Now, we'll create a report to monitor production and supply. For that, we'll use a bill report function. It takes two arguments, a list of values and a list of titles, as you can see. We color gray to identify reports from the rest of nodes and take out the input links. Exploring its result as table and graph. we can see the evolution in time for every item. Zooming in time. You can see, for example, that's the demand, that's the production, and we have stock to fulfill that demand. That's why the supply-demand matched the total demand, but as a consequence, the stock decreased over time. Now we will calculate the percentage of supply-demand compared to the unrestricted demand. And then the revenue projection that will be defined as the unrestricted volume times the percentage of supply times the projected price. There it is. Finally, we'll model costs through an input table of unitary costs that, multiplied with production, will allow to estimate the total cost. Then we'll calculate the projected margin, define it as obviously revenue less cost. Finally, we'll create a report, a final report as follows. Okay, now we'll organize the diagram of our code. For that, we'll create several text blocks. And move the nodes to align them. Now we're ready to create our input-output user interface. We start clicking on the interface icon in the left menu, and then on New Interface, it will open a blank canvas with an empty block. Let's add a new block and bring the diagram inside it. Next, we will start splitting blocks to define the user interface layout we are looking for. Pressing Shift and click will pick elements from the diagram to drag them to their corresponding space. Pyplan interprets the type of node and assigns a predefined visualization when dropped. Input table to yellow nodes, selectors for indexes, and standard tables for the rest of nodes. Then we can resize and move blocks to get the desired layout we are looking for. Specific elements can be added clicking on the type we are looking for, and then search for the node that contains the data we want to display. The user interface is automatically synchronized along common indexes. Item type in this case. Finally, we are ready to close the interface edit mode. Let's now open a more developed UI. Here you find the same blocks we have just created with some additions to provide a more comprehensive decision support dashboard. You can interact with the app through the user interface. For example, changing discounts in this case, and explore the impact all across the model. Let's, for example, explore what happens if we change the unitary cost. The conditional format set to the margin line highlights when numbers are negative. So in this case, if the cost becomes too high, you can see how that works. Finally, we can publish our app through the Pyplan server. Pyplan automatically generates a shareable link you can send to final users for accessing the application user interface.